Hello everybody. Section 7.4 talks about solving rational equations. When we talk about rational equations, we're talking about equations in which expressions on either or both sides are rational expressions, that is, polynomials over other polynomials. Now the key here, if you're going to solve a rational equation, is that we want to clear the denominators away by multiplying both sides by the least common denominator. And this is similar to something that we've done in the past when we've had fractional equations as well. In this particular case, the fractions are formed by a denominator that has a variable. And there are two variables right here. We can see x minus 1 and x. So if we were to combine these two fractions, what would be our least common denominator? Well, in this case, our least common denominator will be the quantity x minus 1 times x plus 1 times x, pardon me, x times x minus 1. There we go. That sounds better. Okay, so how do we do this? Well, if we multiply both sides by the least common denominator, you'll see something like this. X times the quantity x minus 1, and very often I treat it as though it's over 1, would be multiplied on the left-hand side by 2 over x minus 1. On the right-hand side, x times x minus 1, the LCD, again, we can treat it as though it's over 1, is multiplied by 3 over x. And the reason why we want the least common denominator is because now we can cancel any common factors in the numerators and denominators of our multiplication. We note that x minus 1 is the same for the numerator and denominator in this case, and x is the same for the numerator and denominator on the right-hand side of our equation. So we can now rewrite our expression as 2x on the left-hand side is equal to 3 times the quantity x minus 1 on the right-hand side. Now, if we do a little bit of algebra here, we'll find that 2x equals 3x minus 3. Subtracting 3x from both sides to gather our variable terms to one side of the equation, we get negative x is equal to negative 3. And we should divide out the negative. That gives us x equals positive 3. Now, no solution is complete here, especially when it comes to rational equations, without checking your solution. And we're going to check the solution right here by substitution into the original expression only. Got that? The original expression. So we're going to substitute in 3 here. 2 divided by 3 minus 1 should be the same as 3 divided by 3. Well, of course it is, because 2 over 2 gives the same result as 3 over 3. In both cases, both of them are equal to 1. And we're done, at least with this example. Let's try another one here. Let's see how it works out with something else. Let's try this one right here. This time I've got a fraction that has a little bit more to it than just a single fraction. We notice, however, that there's only one kind of denominator that we really have to worry about, and that is the quantity x minus 3. So that is our least common denominator, and we'll multiply it on both sides in order to clear the fractions. Well, here's what happens. Every term on both sides of the equation get multiplied by the quantity x minus 3. And again, I'm going to treat it as x minus 3 over 1 for the purposes of making it a little easier to see what's going on. This will be times 2 over x minus 3 plus 4. And that's 4 over 1 when we treat it for the purposes of this fraction. On the right-hand side, same deal. We're multiplying by x minus 3 over 1 times the quantity 6 over x minus 3. And so what happens here? Well, let's see. Remember that this x minus 3 is distributed to both the first fraction and the second fraction. So we're going to be taking x minus 3 times 2 over x minus 3. Well, that just gives us 2 because the x minus 3's cancel, plus 4 times the quantity x minus 3. And on the right-hand side of our equation, x minus 3 over 1 times 6 over x minus 3 is just 6. So now we can do our algebra and solve for x here. Let's take a look. 2 plus 4x minus 12 will equal 6, which is to say 4x minus 10 is equal to 6. We're going to add 10 to both sides to get 4x is equal to 16. And so our solution here looks to be x equals 4. But of course, we should make every effort to check. And we check by going to the original equation and seeing what works here. So in this case, in my check, I substitute in 4 everywhere I see x. I get 2 over 4 minus 3 added to 4 should be the same as 6 over 4 minus 3. The result is 2 over 1 plus 4 equals 6 over 1. Well, yes, it is. That's true, right? 2 plus 4 is 6, and 6 over 1 is 6. So that's good for us. All right, one more along these lines right here. Let's try this next one. We've got 5 over 2x minus 3 equals negative 2 over x plus 1. Again, there doesn't appear to be any common fractions here, any common items among the denominators, so we're going to take our least common denominator in this case to be the product of these two denominators, 2x minus 3 times x plus 1. Well, let's work that out and see what happens. 2x minus 3 times x plus 1 times 5 over 2x minus 3. Since I've got a fraction over here, what I'm going to do is I'm going to take my LCD and put it over 1, so I recognize the fact that things are going to cancel, will equal 2x minus 3 times x plus 1, and I'll place that over 1 as well, so I recognize the fact that things are going to cancel, would be multiplied by negative 2 over x plus 1. Let's see what happens in this case. If we cancel our common factors, and it looks like the 2x minus 3 goes on the right, and x plus 1 on the right, 2x minus 3 on the left, we're going to get 5 times x plus 1. On the left-hand side would equal negative 2 times 2x minus 3 on the right. So we need to do some algebra right here. Let's distribute 5x plus 5. And on the right-hand side, negative 4x plus 6. Don't forget to change those signs when you distribute your negative. We add 4x to both sides to get 9x plus 5 equals 6. We subtract 5 from both sides to get 9x equals 1, which gives us a solution that looks like x is equal to 1/9. Uh-oh, fractions. Fraction time, which means we're going to have to do a little bit of fraction work to check our solution. Let's go ahead and do the check here. Everywhere we see x, we have to substitute in 1/9, which means we're going to have to take in our fraction here 5 over 2 times 1/9 minus 3 should equal, if we've done everything correctly, negative 2 over 1/9 plus 1. All right, well, a little bit of fraction magic here is required, and if you recall our fractions within fractions in the last section, the complex fraction, we had something like this as well, right? We had 2/9 minus 3, and we could have had negative 2 over 1/9 plus 1, and I'm not even going to bother adding my fractions in the denominators of these two because the common denominator for each of them is 9, and just a multiplication by 9 is going to clear out the fraction within the fraction. And I do the same in the numerator and denominator of the fraction on the right, and we see what happens that in the numerator, 9 times 5 gives me 45, In the denominator, 9 times 2/9 gives me 2. 9 times 3 gives me 27. And that should be the same as if I take negative 2 times 9 on the right, which is negative 18, over, distributing my 9. 9 times 1/9 is 1. 9 times 1 is 9. 45 divided by negative 25 should be the same, if we've done everything correctly, as negative 18 divided by 10. Is it? Well, let's reduce our fractions. 45 and 25 are both divisible by 5. That gives us negative 9/5. And if we divide on the right by the common fraction factor of 2, it looks like we get negative 9, and 10 divided by 2 is 5 as well. So negative 9/5 equals negative 9/5. Hooray! It works out. Okay, more in the next videos coming up.